Assalamualaikum and good day to everyone. My name is Madam Fadiatul Hasinah binti Muhammad. Today we will continue chapter 2, which is motion in one dimension. For today, we will cover subunit of chapter 2, which is 2.4, free falling object. At the end of the session, students should be able to apply the kinematic equation for constant acceleration to free falling object. A freely falling object is any object moving freely under the influence of gravity alone, and it's not depends on the object's original motion. All objects falling near the Earth's surface fall with a constant acceleration. Acceleration tells you how fast the velocity changes for every second. The acceleration is called the acceleration due to gravity and indicated by the symbol of g. The value or the magnitude of g is 9.80 meter per second square, and g is always direct downward, which is toward the center of the Earth. It's conventional to define up as a positive and down as a negative. So, in this case, the gravitational acceleration is A equal to negative g equal to negative 9.8 meter per second square. Ignoring air resistance and assuming g doesn't vary with altitude over short vertical distance, free fall is constantly accelerated motion. Okay, let's do a simple experiment before we move further. A ball and a light piece of paper are dropped at the same time. Guess which one is true? A. The ball and the paper reach the floor at almost the same time. B. The ball reached the floor first before the paper. C. The paper reached the floor first before the ball. So, what's your answer? The answer will be B. The ball reached the floor first before the paper. Okay, before we look at the explanation, let's look at the experiment 2. A ball and a light piece of papers are dropped at the same time. Actually, this is same as experiment 1, but now the paper will crumple up. So, guess which one is true? So, the answer will be A. The ball and the paper reach the floor at almost the same time. Can you explain why? The greater the surface area of the paper, the greater the effect of air resistance. If you can eliminate the air resistance completely, then both objects will hit the ground exactly in the same time because they only have the influence of the same gravity, which is Earth gravity. This is another example effect of air resistance. Near the surface of the Earth, all objects experience approximately the same acceleration due to gravity. Free fall is the motion of an object subject only to the influence of gravity. In the absence of air resistance, all objects fall with the same acceleration at a given location on the Earth, and in the absence of air resistance, all objects fall with the same constant acceleration. The expression of free-falling object doesn't necessarily refer to an object dropped from rest, but it also refers to the object thrown upward or downward. For object drop, initial velocity is 0, so V0 here is initial velocity. Let up be positive, down will be negative. Generally, we use y instead of x since free fall is moved in the vertical motion. The gravitational acceleration is g equal to negative 9.8 meter per second square as g is direct downward. For object thrown downward, the initial velocity not equal to 0 as we thrown the object with the velocity. And the initial velocity will be negative because of the object is thrown downward. For object thrown upward, initial velocity is upward, so it will be positive. The instantaneous velocity at the maximum height here equal to 0 because of at this point object will stop for the moment before it turn back to the ground. The gravitational acceleration g is negative 9.8 meter per second square everywhere in the motion as g is direct downward. This is example of the symmetrical motion when time to reach the maximum is equal to the time to hit the ground or to reach the initial point. They also have a motion where it is non-symmetry or called as non-symmetrical motion. Later I will show one example on the non-symmetrical motion. If we have the non-symmetrical free fall situation, we need to divide the motion into segments. The possibilities include upward and downward portion. So, this is the situation for symmetry and this is for non-symmetry. Okay, just want to recall back all the equation that you have learned in subtopic 2.3. This is all the equation I use in situation with uniform acceleration. Okay, now let's look example 2.8 taken from 11 edition survey textbook, page 50. A ball is thrown from the top of a building with an initial velocity of 20 meter per second straight upward at an initial height of 50 meter above the ground. The ball just missed the edge of the roof on its way down. Determine A. The time needed for the ball to reach its maximum height. To find the time needed for the ball to reach its maximum height, first thing you need to do is list down all the information given from the question. You have initial velocity v0 equal to 20 meter per second, y0 equal to 0, y0 is the initial position of the person, t equal to 0, t is the time just before the ball is thrown upward. Then you need to identify which equation you want to use. You can use equation V equal to V0 plus AT or AT plus V0. As you know that at maximum height, V equal to 0. By calculating this, you can find the value for time needed for the ball to reach its maximum height or T equal to 2.04 seconds. Again, you need to remember that the gravitational acceleration always equal to negative 9.8 meter per second square as gravity is downward. For B, find the maximum height. Again, at maximum height, V equal to 0. By using the equation delta y equal to y minus y0 equal to v0 t plus half a t square. So, you need to find the value of y here. So, you will get the value of y maximum equal to 20.4 meter. Alright, so now look at question C. Question asks to find the time needed for the ball to return to the height from which it was thrown and the velocity of the ball at that instant. Means that question need to find t here. Okay, let's identify which equation you want to use. You can use equation delta y equal to v0 t plus half a t square. Okay, delta y equal to 0. Because of at this original position, y equal to 0 minus initial position equal to 0. So, by calculating this, you can find t equal to 4.08 seconds. Actually, there are another way to find t at this position. Because of previous, you have find t at the maximum, right? So, due to this symmetrical motion, when you have t at the maximum point, you can times by 2. You will got the t at this position. So, t will be 4.08 second. Okay, now look at for velocity of the ball at that instant. So, you can use equation v equal to v naught plus at. Again, a is the gravitational acceleration, mass equal to negative 9.8 meter per second square, as gravity is always downward. So you got the negative value for velocity, which is negative 20 meter per second. Negative is referring to the velocity of the ball downward. Alright, so now look at for question D, the time needed for the ball to reach the ground. So question asks to find t right here. Okay, so you can use equation delta y equal to v naught t plus half at square. Again, we use delta y equal to negative 50 meter because of we set y is negative below the 0, meaning that this is your reference point here, y equal to 0. Anything above 0 will be positive, below 0 will be negative. So that's why your delta y will be negative 50 meter. By calculating this, you can find t equal to 5.83 seconds. So, last question. Question E, the velocity and position of the ball at t equal to 5 seconds. You can try by your own for this question, yeah? Alright. Okay, now let's look example 2. Suppose that a ball is dropped from a tower 70 meter high. How far will it have fallen after a time t equal to 1 second and t equal to 2 seconds? Please ignore air resistance. Okay, you need to list down the information given, which is a ball is dropped, meaning that initial velocity equal to 0. Height of the tower is 70 meter. Time given is 1 second and 2 seconds. Okay, then you need to identify which equation you want to use. You can use equation delta y equal to y minus y naught equal to v naught t plus half at square. Now we do for time 1 second first. So, delta y equal to 70 meter. V naught equal to 0, t just substitute with 1 second plus half at square. Again, a equal to negative 9.8 meter per second square. Negative sign you can put here or here, doesn't matter. You still get the answer, negative 4.905 meter. Then same goes to the time equal to 2 seconds. Just substitute t with the 2 seconds and t here with the 2 seconds. You can get the negative 19.62 meter. Note that all answers are negative because of the final position is below the initial position, which is downward. For summary of free fall, every object that moving upward will have the positive velocity, while moving downward will have the negative velocity. The gravitational acceleration always negative 9.8 meter per second square everywhere in the motion, as the gravity is direct downward. Since free fall object is about moving in one direction, we only refer to the y-axis. Thanks for watching.